There, come back to the Technology Innovation Hub. It's going to be a session from Oracle portal. Let me share the screen. You may remember we stopped our traditional non-multitenancy architecture on this discussion about the parent process IDs, child processes, and no PIDs. And I may remember we went through the details about the top command as well. So that is where we stopped. Let's continue from there. So up next, let's start deep dive in the memory structures. Memory structure deep dive. Previously, we just discussed the high-level memory components. You may remember that we went through the shared pool and DB cache, redo log, as well as. So we discussed the program global area and those as well. But that is in terms of memory structures, we went through only high level definitions only. We didn't went into more detail. So now let's start the deep dive in the components. The very first component is going to be the shared pool. Shared pool. So let's get into more details with regard to shared pool. If I just take you to back, this is what we have done. Remember, we just identified the components within the shared pool. So components, you may remember library cache, direction cache. We just had a very brief introduction. And we got to know it is a component within the SGA. You can see the other components as well. And after that, we just went through into more detail with regards to the granular and all. Then I'm just recalling what we have done up to now. And database memory management, the parameters and automatic memory management, we discussed those things. Then this is what basic memory structures. We discussed under that the program global area, PGA. You may remember we discussed the dedicated server environment and shared server environment, and those things were discussed up to now. And how the large pool behaves when it comes to the shared server. And we discuss the program global area components will be moved to large pool. These components use a global area and all. So those things are done, and definitions were given for PGS and all, and likewise. And basic memory structures under that again, private SQL area, shared SQL area, how the SQL statements is going to work within SG and PGA, and how the dedicated server is going to manage the private SQL area and shared SQL area and those things. So we have done those things up to now. That's why having understanding that details, basic details. So this is what it says, high level overview completed. So after this place, high level overview completed. And now it's time to deep dive the components. That's what actually we started on the process side, because you may remember we had basic process architecture as well. So on the basic memory architecture, we have completed the high level architecture. So these areas are done now, high level. Now that is what we are trying to start deep diving the component within the SGA. That is where I'm going to start the shared pool now. And the basic process architecture also we have discussed. So that is where we stopped. So the client process, server process, you may remember we went into doing practicals in detail, process IDs and all inside the server side, inside the OS side, and we went to details. Okay, so just to recap what we have done very quickly, and finally we discuss about threaded execution parameter aspect. Now in this session, let's start, as I mentioned, we are going to deep dive the memory structures. First thing is shared pool. So if you want to have the basic understanding, please go and check the previous videos on where the basic memory structure details are given, the high level overview of the memory structures. Now under shared pool, now we know shared pool is one of the main memory structures within the system global area. That is, we are aware. And you can see shared pool. The shared pool is a component of system global area and is responsible for caching various types of program data includes execution plans, parse SQL, and PLSQL codes, contains from data dictionary. Yeah, so let's try to understand these things slowly. We don't have any hurry here because now we are trying to deep dive the component. Now in deep diving components, we need to do it little by slowly because we need to understand how the internal components works together. In component introduction also will be done after explaining the after deep dive in memory components, we'll be doing how these components are going to interact with each other. So that will come in the next sessions. And in shared pool, how you know it is within the database instance and within the SGA. So that is what system global area. So in the shared pool, mainly we are going to have a component called library cache. So this is a major component. So that's what is mentioned in bottom as well. There's some component called library cache, and after that we are going to have the dictionary cache, DDC. Of course, these two we know because on the basic memory architecture we discussed about the library cache and the dictionary cache, but we haven't discussed about the server result cache and no. So these are additional components, server results cache, and we are going to have inside the library cache we are going to have shared SQL area. Now you know this one by now because we have discussed these things. And private SQL area only in shared server environment. And we are going to have more components. This large pool will be discussed later because why this is there. I think you remember we discussed this one in shared server environment. This private SQL area may be in large pool or maybe in shared pool. If large pool is defined, the private SQL area is going to get moved to the large pool. If large pool is not defined in shared server environment, then only this private SQL area is going to locate in the shared pool. So that is how it's going to work. And you may remember these components shared in shared SQL area, we are going to have the execution plans. Execution plans in a sense, the past SQL statements. The execution plans is going to be the input for the optimizer, Oracle optimizer for further optimization before fetching the data. And these statements, any execution plans which are going to locate here will be shared across all the users. You may remember we learned this one before the statement comes here in a dedicated environment. Within the PGA, it is in the private SQL area. You may remember that we have learned those. And when you go down, now execution plans are, or the past SQL statements are stored in library cache. And this is data dictionary cache. So data dictionary cache is going to contain information taken from the Oracle data dictionary. Because now we know in Oracle data dictionary we have the definitions of objects. Object means you get a table as object, table name, number of columns, column length, column data types, everything is there in data dictionary. So this is a cache. Oracle data dictionary is located in system DBF file. So this is a cache from that. And we know about database files, system DBF files, and sysops, undo DBF files. Those things are there on Oracle database, physical components. And this is a cache from Oracle system DBF file, database file. And it helps when it's trying to generate the execution plan. The server process has to generate the execution plan on behalf of the user request who is issuing the SQL query. And when the execution plan generates, I think we may remember we discussed these things in the past. In this also pass only the execution plan. Because in past, what's going to happen? Syntax checks, semantic checks, all things are going to happen. Now, syntax check means we know the statement has to be syntactically correct. Semicolons and those things cannot be mistakes cannot be happens. Comma, semicolon has to be there in the correct places syntactically. And the semantics is where these object names and column names and object data types and everything is going to check. Now to check whether, let's say for example, this query select star from employees. Now this employees is object. Now this object must exist in the database. No? So who is going to verify for the server process? This object is already exists in the database. So that's where the dictionary cache is aware about the object because this is a cache from system DBF file. If such object exists in the system DBF file or in the Oracle database, data dictionary should have those information. So this is a cache from it. Before, let's say when Oracle will generate the execution plan, it needs to verify such object exists in the database. So then what server process will do, it will check against the data dictionary cache to identify whether such object exists, called employee. Then after that, it will go on to column name checks, data type checks. So those are known as the semantic checks. So on the way to generate the execution plan, Oracle has to go the syntax checks, semantic checks, likewise. So semantic checks are what? Object name checkings, column name checkings, and those. So for that, data dictionary cache will be helping. So that is that data dictionary cache. Then comes the server result cache. So server results cache, actually we have two components: SQL query results cache, the PL/SQL function results cache. So we will discuss with detail about this one later. For the time being, I just give you the definition. Like this now, the result caches are very important because okay, now let's say when Oracle execute a query, maybe a select query, and for that particular query, there's output going to come. So that output, if it can keep it in the cache means in the memory within the shared pool. Now this is a component inside the shared pool. So the results cache is a component inside the shared pool. So when the maybe another user or the same user requests the same select query, he no need to calculate and get the result again, because result is already ready-made available in the cache. So that's the purpose of server result cache. To cache the result, intermediate results or final results of a SQL query, it will cache, so that the second time it can just paste the data directly from the cache rather than just again calculating the data and fetching from this as well. So it is time saving and very fast. So that's what going to happen, the server results cache. And anyway, from Oracle 12 onwards, or by default, this cache is available in shared pool. Server results cache. So Oracle initially, whenever query is executed, it will try to cache it in the server results cache. So it is available. And we discuss more detail because server results must scans and those details are there. And oh yeah, for SQL query result, there's a one area, and for PL/SQL, there's another area. So there are two separate areas, one area for SQL, another area for PL/SQL for caching. Function results of a function will be stored in the PL/SQL. Just the results of a SQL query will be stored in this area. Very soon. Yeah, we have reserved area, reserved pool for, we can reserve area in the shared pool. So as I said, we'll discuss more detail about these things later. And we have information lifecycle management, ILM, bitmap tables, and these are additional things actually. And NQs and yes, latches, and yeah, so we will discuss the ASH acquisition history purpose and all. Latches are memory, the memory areas which we're going to manage. And we'll discuss anyway those things later, latches, NQs and all. Yeah, so that's just a basic definition. It's a basic definition for this about the components in shared pool. Before going to large pool, so we need to get more details with regard to this component one by one. And let's do some hands-on as well. So I'm going to refer to this note for these explanations. If I just show you that one, because you may remember we have been referring to two guides for the explanation of this database architecture. One document we have been referring to this technical architecture document. You may remember this one, we have used this. So in the technical architecture document, there are details given. So we can go to it, of course, even you can go to it. So this is what the same thing that I have explained is available. But I am thinking before getting to more theoretical explanation, let's try to do some hands-on here about the shared pool, so that you can get a more understanding with hands-on what's happening inside the shared pool. And after that, let's come back to a theory and get it explained. Fine, let me just switch to the practical environment. Okay, let's try to do a small practical like this. I think I'm in a 19C database. Yeah, that is not, that is a 12C one. Let me just come back here. Yeah, so I'm in a 19C database, non-container database, that's fine. So this is the same database that we prepared under the very first Oracle portal. We just did the dual installation. We just had 12C, 19C in the same virtual machine, so it's the same environment I'm using. Now, the practical, let's do something like that. The very first command I'm going to type, select this one. I'll be uploading these guides so that you can do the practicals later. Now, this is something but select start from SG statistics where pre-memory, where name like pre-memory and pool, share pool. So if you want to find how much of pre-memory number of bytes available in, so I'm having at the moment 32 megabytes, yes. Yeah, so 32. 32 MB is there as pre in my share pool. So that is what share pool in my case. If I just do another command, select this one. Select namespace, pins, ping hits, reloads, invalidations from video library cache. Now this is another output from video library cache. Because as per this one, you may remember I explained, library cache consists of what? Mainly the execution plans. So inside the library cache, we can identify namespaces. Namespaces, for example, now we have a lot of namespaces here. So for SQL, we have separate namespace. Now, if you go down, this is for Java and all, and for each different type of code, we are going to have different type of namespace. Now, this is for SQL, that those things we can understand very clearly. So for any SQL statements, it is going to create the execution plans on SQL area. And we are going to have triggers like PLSQL objects and cursors, functions. So we are going to have separate namespaces for those things as well. So namespace is nothing much, just a different specific memory location for specific object. So we are going to have SQL objects, PLSQL objects. Now SQL objects are like tables we use now. So functions, triggers, and those things are going to be a PLSQL object. Now anything comes on SQL is going to be SQL object, like any queries for tables and also those things are going to be stored in SQL area. And for PLSQL trigger, so trigger is a PLSQL object and it's going to store here, and we have procedures and those things. So at the moment, pins means how many reads are happen, and pin hits out of this much of read requests, how much of hits happen. Cache hit and cache misses are those things are there now. Because now, for example, when server is requesting for a particular execution plan. Now let's say user send a select query. User send a select star from, or let's say select employee number name. Where likewise there's a with the filter is sending a select query. Now for that select query, what Oracle will do initially, it will check whether the execution plan is there available, because that's why initially if the execution plan is there, then that's known as a cache hit. Cache hit means what? It's a swap pass. Swap pass means Oracle can find the execution plan within library cache. So if the execution plan is available, it becomes a swap path. That means no need to generate the execution plan from the beginning. Syntax check, semantics check, those things no need to do, because it can find the plan in the library cache. So that is a swap path. If the plan is not there in the library cache, that becomes a hard pass, as well as going to be a cache miss for him. So cache hit is always a swap path. That means a particular execution plan which is where his or a server process is looking is available. If the particular execution plan where server process is looking is not available, that's going to be a cache miss. And we can see the out of this much of selects, out of this much of search, this much of hits has happened. Pin requests and pin hits. So cache misses and cache hits like that. So you can see this my environment, out of this much of request, this much of hits have been done. So we can calculate the cache hit percentage. So likewise, so I think that I haven't taken that one into consideration here, but for each namespace we can get the percentage. So that is not that much necessary at this stage because we are the one understanding the memory architecture components. When we discuss about library cache and especially the sharp pole tuning the sharp pole, then we can discuss those things about the hit ratios and miss ratios and those things. So for the time being, just try to get the idea about the namespace and all. And here number of reloads are there. Reload means due to cache misses, Oracle has to regenerate the execution plan and all. So let's discuss those things under tuning, but just get to know within the library cache there are namespace for different type of object types, SQL objects, PLSQL objects, and likewise, and Java also there. Fine. And so that is that query. The previous query is pre-memory. Okay, so let's show parameter sharp pole size. So yeah, so this will give the current sharp pole size in my database. Let's check that one. Sharp pole size. Yeah, it is not defined because I think I have enabled automatic memory management. Let's see show parameter. Let's see. Yeah, my C target is on. That means I have enabled automatic memory management. So that's why this sharp pole size is 0 because it's managed automatically. But at the moment with automatic management, I have this much of pre-bytes. So this is in bytes, no? So we can go for kilobytes and megabytes. Yeah, it is 329 MB, not 32 MB. It's around that 329 MB is available. Anyway, that's okay. So pre-memory, that much of pre-memory, that is an automatic memory management. So that's why the value is 0. I can put a value, but no point. I have enabled automatic memory management. So let's discuss about automatic memory management and those things later under memory management. But I have given the definitions, I think. So there was a slide in previous slides. There was a place which automatic memory management was explained. And that is that command. Then, yeah, we have reserved size, sharp pole reserved size. Just you can check it. Show parameter sharp pole reserve. Yeah, sharp pole reserve size is available at the moment. How much? This is also in bytes, 327 MB. Yes, so if you want to get more details about that, you can just put a, let's see, and this is easy way to get the definition and more detail about this sharp pole reserve size. So you can right away go for 19C. So this is one the documentation says sharp pole reserve size. You can see it specifies in bytes the sharp pole space that is reserved for large contiguous request of sharp pole memory. Yeah, the sharp pole is actually working in LRU method, least recent use algorithm. We know what is LRU. I mean, if the certain buffers or certain execution plans or certain memory structures are in use frequently, so those things will be pinned or available within the sharp pole. If certain things are not in use for certain time, that means it's going to be least recent use, or least recent use means those things going to get cleared, going to get destroyed. So that's the algorithm, LRU algorithm. But if you have defined reserved pool, now reserved pool is not going to work in LRU algorithm. That is for large memory. I mean, if there are now, for example, let's say under shared server architecture, Oracle is going to, if large pool is not defined, it is going to use the shared pool. So in that case, shared pool reserve size will be useful, but there are other cases also. You can use this parameter to avoid performance degradation in the shared pool in situation where pool fragmentation forces Oracle to search for the pre-memory chunk of unused pool to satisfy the current request. Yes, I mean, whenever Oracle needs the contiguous memory allocated in the standard sharp pool is not enough, Oracle will look for large memory spaces. So in that cases, this will be useful. The reserve share pool size. That's what it says. But for the time being, just leave it. We are going to come back and discuss this one in more detail. Share pool, this reserve size. Yeah, so that is that. And yeah, I think the practical is continuing. Set a line here. So this is about flushing share pool. Fine. So let's do this practical in the next session, having understanding about the reserve pools and a little bit of theoretical aspect. So let's understand a little bit theoretical aspect, and after that, let's come back to this share pool, flushing and all. So I'll meet you in the next session. Have a great time. And if you like the session, you can subscribe. Now I think in the videos, you will get that bell icon as well. So it's been enabled. So you can put the subscribe. So and click the bell icon as well, so that whenever any video is published in the channel, you'll be notified. Fine. Have a great time. I'll meet you soon. Bye-bye.